Hello everyone, my name is Diego Romeres and today I'm going to present PYROBOCOP, which is an open source software for solving control and optimization problems in robotic manipulation tasks that can handle contacts and obstacle avoidance. This was a work done at MERL with my colleagues Arvind and Devesh. So what is PYROBOCOP? Let's assume that you have a task, a manipulation task in example, and you have a robotic manipulator that wants to flip a gear. What the user has to provide are the dynamics of the systems that we want to control, all the constraints like the contact constraints and the objective functions. And we provide some community classes in order to do so. Then PYROBOCOP transforms the continuous times problem to a discrete time problem in order to have a finite number of constraints. It transforms the problem into a nonlinear program with complementarity constraints that is called, that is a mathematical problem with complementarity constraints. And we can handle the complementarity constraints internally and solve them. Once we have formulated the problem, in the backend, we paired with two tools, the solver IPOPT and ADOL-C that provides automatically the derivatives of all the constraints to the solver. These are both open source tools. And then PYROBOCOP can solve our MPCC problems. And in case it gives us back the optimal control input and the optimal trajectory. So to summarize, the main features of PYROBOCOP are we can handle constraints like contacts with complementarity constraints. We can do obstacle avoidance with a new formulation that we have provided that yields again to complementarity constraints. We transform the optimal control problem into a nonlinear program, and everything is open source and based on standard Python. Okay, what can be interesting for you? So what can you actually do with PYROBOCOP? So as we just saw, we can solve trajectory optimization problems. We can solve minimum time problems. We can even solve problems if you have multiple modes in sequence, and PYROBOCOP can decide the time horizon of each of the modes. We can also do parameter estimations for systems with complementarity constraints. And we can also solve optimization problems when the models are given by machine learning techniques. Okay, just some example to simplify this even more. And you can find the code for all these examples in our repository. So we have standard classical problems like double inverted pendulum, carpal with inverted pendulum, and soft walls that give rise to the complementarity constraints. Here we have a car that is parking in between obstacles. Here we solve the dynamics of the balls with a Gaussian process, and then the optimal trajectory was given by PYROBOCOP. Here we solve manipulation problems where a robotic manipulator has to wrap this orange belt in between these two pulleys. As multimodal examples, we have pushing examples where we go from sticking to slipping contacts and avoid obstacles. And we have other minimum time problems and some examples of estimating parameters in complementarity systems. Some results, here we are just showing off some pushing examples with obstacles. Here is the carpal with soft walls that the green line and the red line are the soft walls. Here is the example of the belt drive unit where you can see that PYROBOCOP can handle the modes with and without contacts and elasticities. And this is it. If you are interested, you can download our software on our website. Of course, it's open source. We have detailed instruction on how to install it, but it's fairly convenient. We also provide a code environment. And then there is a package guide where I describe in detail, step by step, one example and how to create your own one. Thanks for listening.